I'm Kurt Hunterman. I was one of the archaeologists who worked on the excavation at Driffield Terrace in 2004 and 2005. First excavation was carried out at 3 Driffield Terrace, and that was the first one to identify some unusual burials. There were quite a few decapitations visible during the start of the excavation, and that just carried on. So we knew we had something unusual at the site, and about 6 months later we had a chance to excavate another group of Roman burials close by at 6 Driffield Terrace, and they displayed very similar characteristics, high degree of decapitations. After the excavation we carried out osteological analysis of the human remains, and they indicated that there was a greater number of human remains had been decapitated. We just hadn't seen them during the excavation. The heads had been placed back in the correct position in the grave. Furthermore, there was evidence for trauma on the remains, including blunt force trauma, which indicated that these people had been hit by kind of heavy objects but hadn't actually cut the individuals. Those remains indicated that these had healed, so these people had this trauma and had then lived afterwards. In contrast, we had sharp force trauma on a number of the individuals, and these generally hadn't healed, indicating that they'd died violently. The population was predominantly adult male, and they were generally fairly well built. So it suggested that we had an unusual group of people who for some reason had been buried together in one part of one of the Roman cemeteries in York.
This is the skeleton of a man who was aged between 26 and 35 when he died, and like many of the other skeletons found, he was decapitated. The cut is on his second cervical or neck vertebra, so it's actually quite high up, close to the skull, and it was delivered from above and behind, so sort of in this direction. It went through the bone, and you can still see that it left quite a smooth surface here, which means that it was made with probably with a bladed weapon. He also has some other injuries. For example, here on the skull there is a very shallow depression, just sort of here. It healed quite well. It was caused by a blunt instrument or tool, and normally when you find this on a skeleton it suggests interpersonal violence, so fighting, or it could be caused by things falling as well. But he also actually has some chipped teeth at the front, who are also associated with fighting quite often. This man was also affected by degenerative joint disease during life, which is something that happens normally later in life, but you can see it on younger individuals in ancient skeletons. And you can normally see it because new bone deposits around the edges of joints or around the edges of the vertebrae. In the case of this individual, it's concentrated on the lower spine and on the edge of the clavicles as well. This individual also had a Schmor's nose, which are small depressions that form on the flat surfaces of the vertebrae. Nobody really knows exactly what they're caused by, but it is thought that they're associated with physical activity or intensive physical activity. And then you can see quite a severe one on this vertebra here. The skeleton also had some injuries on the legs, especially on the lower legs. One of the main ones is a fracture on his left fibula, which is one of the lower leg bones, and you can still see it because of the swelling on the bone. It has actually healed quite well. The bone is still quite straight. And it didn't actually affect the tibia, which is the other leg bone. However, there is a little spike of bone on the tibia here, which may have formed because of soft tissue trauma that is related to the fibula fracture. And on the tibia as well, we have what is probably an ossified hematoma or a bruise, which instead of being absorbed again has turned into bone. And it's this sort of shiny area of bone that you can see here.
My name's David King and I'm a radiologist. So I'm a doctor at York Hospital, and my job involves using X-rays and different sorts of scans to diagnose bone and joint injuries and other diseases of the bones and joints, among other things. For this exhibition we used a CT scanner to get pictures of some of the bones of the people. And to understand how a CT scanner works, it's useful just to understand how an X-ray is taken first. So with an X-ray, originally a photographic film was put behind the part of the patient being X-rayed. These days we would use an electronic digital detector, and the X-rays are shone through that part of the body, and that will blacken the film or be detected by the detector plate. And the more dense tissues, like the bones, come out as whiter on the picture, and the less dense things like hair are blacker. So there's a grey picture formed. A CT scanner also uses X-rays to create the picture, but this time the detector, instead of just being fired once from the front, rotates in a circle around the area being scanned, and also the area being scanned will move through the scanner at the same time. So what you end up with is a whole volume of information about the densities of the tissues. And then using a powerful computer you can reconstruct that to show slices through that bone or that part of the body, or you can use the data to make a 3D picture. And we've used a combination of both of those for this exhibition. So this is the person whose head and neck we scanned. We had to put the bones where they would normally be in relationship to one another because the person had been decapitated. So we scanned the whole of the head and the top of the cervical spine, which are here. These are the bones in the upper part of the neck. And then we reconstructed to get a picture that was a slice straight down the middle through the nose and through the middle of the neck, like that. And so that's what this picture is. And this is the skull at the front and the nose here and part of the upper jaw with a tooth. And this is the top of the neck bones here. And this black line across here shouldn't normally be there. And when this person was decapitated, this is where the blade sliced through this bone here. And I can show you another picture of that. And this time we've reconstructed in this direction, so it's like a slice coming down like this through. Just one of the bones at the very top of the neck, so the second one down in fact, and here we've got this cut across the bone, so a very strong blow with a blade has cut straight through the bone and cut the head off this person.
My name is Rui Martiniano. I'm a researcher in the field of ancient human genomics, and what we do is to study ancient specimens from archaeological sites and compare these with other present-day individuals and other ancient individuals and try to investigate past demographic events. During the last 30 years, people have been trying to extract DNA from ancient humans, but this has proven to be very challenging. There are several issues. One of them is contamination, both contamination from the soil bacteria, as contamination from other humans that might complicate our analysis. Also, the ancient DNA that we obtain from these archaeological sites is very degraded, and all this needs to be taken into consideration when starting the lab work. The lab work, we normally enter a clean room environment that has been sterilized completely. We have to wear a whole bodysuit and a mask, and it starts normally by drilling the bone. We then take that bone powder, we extract the DNA out of it, and we sequence several millions of sequences that we then use to call mutations and compare these ancient samples with other present-day individuals and other modern populations. Regarding the Driffield Terrace samples, we analyzed 7 samples belonging to the Driffield Terrace archaeological site, but also 1 Anglo-Saxon sample and 1 Iron Age sample, because we wanted to investigate how the genetic composition of the people of the British Isles has changed throughout time. And what we realized is that the Iron Age sample and the Driffield Terrace samples were extremely similar genetically, but one of the Driffield Terrace samples was more similar to Middle Eastern populations, such as Palestinians and Jordanians. What we then did afterwards was to try to resolve the ancestry of these ancient Driffield Terrace samples further by investigating on a very dense data set of British populations in order to determine what was the genetic contribution of these ancient samples to the present-day British. What we realized is that the majority of the Driffield Terrace samples were more similar to Western peoples of the British Isles, such as the Welsh and as the Northern English, for example. And the Anglo-Saxon sample was instead more similar to Eastern British populations, such as the peoples from East Anglia and York. What this tells us is, one possibility is that the people that inhabited here, the Iron Age people, then had continuity during the Roman Empire, and that's what we see in the Driffield Terrace samples. But then afterwards, a migration from Germanic tribes from continental Europe comes in and really affects and really contributes to the populations in the east of England. Regarding our new findings about Driffield Terrace, we can say that this would fit a scenario where these samples could be gladiators, because other burial places have been found with a similar profile, but it is also within possibility that these samples were part of the Roman army, because we know from historical evidences that the Roman Empire would enlist local people. So in final terms, we can say that we identify one sample that has a very distant origin, and this really shows the cosmopolitan nature of the Roman Empire with a lot of mobility, and there was already archaeological evidence for such mobility, but we have now a genetic evidence added to that. And besides that, the other samples were really similar to Northwestern European populations, and that's what it tells us is a level of continuity between the Iron Age samples and the Roman Empire.
My name is Janet Montgomery. I'm an archaeological scientist at Durham University, and the topic of my research area is isotope analysis of humans and animals. And this is a method that we use to get information directly from archaeological humans and animals about aspects of their life, such as where they were born, how they moved around the landscape, if they migrated from one region to another, how their diet might have changed over the lifetime and what they were eating, the types of food they ate, how much protein they had, whether they were eating marine foods or foods from the land, such as pork, beef, lamb, grains that were grown on land, and also things like how much pollution they were exposed to whilst they were growing up. So if they were living in an urban environment that might have been subject to quite a bit of atmospheric or other types of pollution, or a rural environment which might have been much more natural and pristine. And these techniques allow us to find out information about people in the past that we can't actually get any other way. They're quite recent and we're still developing them, but at some sites and in some periods they give us some very useful information about humans in the past. So we've been applying these techniques to the burials at Driffield Terrace in York for over 10 years now, and they have given us some really interesting information about how diverse the population at Driffield Terrace was, and some indications about what sort of places they may have come from in the past. So we've used things like strontium isotopes. That gives us information about the type of geology that the individual was living in and sourcing their food from. So if they move from one type of geological terrain to a different one, so for example if they moved from a granitic terrain to a chalk terrain, we can spot that in their teeth. And that's shown us that there's a lot of the individuals buried at York are not from York. They've come from elsewhere, possibly in Britain, even further afield. We've also used techniques like oxygen isotopes. This gives us an indication of what the climate was like in the place where the individual grew up. So if they've moved from a hot climate to a cold climate, we can spot that. And again, at Driffield Terrace, we have some really interesting information. We have people there that have come from much colder climates than York and also from much hotter, warmer climates than York. We also have information from their diets. So again, if people have changed their diet radically or they've moved from a place where types of foods were available that weren't available in Roman York, we can spot that as well. And we have individuals in York who were eating what we call C4 crops. So these are types of grains like millet and sorghum that weren't present in Roman Britain. And we have people at York who had been consuming these foods, and so we can assume from that that they were eating them elsewhere and have moved to York subsequently. So more recently, we combined these isotopic techniques, which are very good at giving us information about the people who did the moving. So they only really work with that colonizing, migrating generation. They don't work with their descendants, but things like ancient DNA do. So ancient DNA gives you information about the genetic ancestry of the person. Not that necessarily they moved, but that their ancestors sometimes in the past have moved. So at York, we combine these two techniques more recently on a group of 7 individuals from Driffield Terrace. And I did the isotope analysis on these, and most of them came back quite normal, what we would expect within the bounds of what we would expect for Roman York. But one individual had a very odd oxygen isotope ratio, and this was off the scale really of anything that we'd obtained from Britain before. It was way too hot, the value that came back. So we measured it again and again. We replicated it 3 times, trying to find out if it was something wrong with the analysis or whatever. And then it came back the same every time. So then after that, I had to go to a meeting where we met with the DNA people and various other people from working on the project to put the data together. And I was a bit worried about this because I thought there was possibly something wrong with the analysis. But anyways, it turned out the ancient DNA showed that 6 of the individuals had genetic ancestry consistent with Iron Age Britain, so Britain before the Romans arrived, but one individual didn't, and his genetic ancestry appeared to come from the Eastern Mediterranean, so Syria, Lebanon, Jordan, that area, and it was the individual that we had the really unusual oxygen isotope ratio for. So the 2 types of evidence agreed. So it was a big relief, 1, that the techniques actually worked, and 2, that the analysis showed that not only had this individual got genetic ancestry from this part of the world, but also that he'd actually done the moving. So he'd moved from somewhere very warm and southerly to York, and so that it picked out the person doing the migration, and also that they had genetic ancestry that was not normal for Roman York at the time.
When we were interpreting the cemetery, we were looking at evidence of the burials, how they were laid out, what grave goods were found with them, anything that would indicate how these people were buried and what that represented about them as a group of people. We knew from the burials that they were laid in the ground with a degree of care. They had grave goods with them in some cases. This suggested that there was a certain amount of respect being given to these people when they were buried. This suggests that they weren't criminals because they're usually buried with no respect, for example, in rubbish pits. Another suggestion was that these were soldiers, The problem with that being that there are so many decapitations, this wouldn't really fit with a soldier lifestyle. The blunt force trauma could, in terms of people being trained and being wounded, but those sorts of wounds healing, and the short force trauma, the result of battle, and these people then dying. While we were investigating the cemetery at the post-excavation stage, we had an interesting discovery made on some of the human bone. That was that there were bites from a large carnivore, in all probability a lion or a tiger. This didn't really fit in with a soldier scenario, and all we could really think of was that this was evidence of a gladiator who fought animals in the arena, either as individual or groups. So it also fits in with these people being buried in a prominent position in a cemetery in York with a degree of care, but also having a very violent lifestyle.
My name is Tim Thompson, and I'm Professor of Applied Biological Anthropology at Teesside University.
And I'm David Erickson, and I'm a PhD researcher and part-time lecturer at Teesside University.
Today we've been scanning these bones. These bones are from a larger collection, and the feeling is that these remains might be gladiators. But there are some very interesting marks on parts of the body, particularly on the pelvis, which may be related to animal bite marks. And so we've been using this method to start the process of analysing those marks.
So what we've got here is a 3D structured light scanner. The 3D structured light scanner projects a form of light onto an object, and by recording the particular dimensions of the light and the waves on the light, we can record the topology of the surface of an object that's placed in front of it. So for example, as the light fires onto this pelvis here, the shapes will bend around the light, and depending on the shapes changing, it will create a 3D model.
We will use these models to start analysing the remains. Because the method is totally safe and non-contact, it means we can scan as many of these delicate fragments of bone as we want. We will then take those back to our lab, where we'll process the data, and it will allow us to start measuring and recording the dimensions of what may be the bite marks. What we will then do, take some bones which have been bitten by animals that we know of, things like lions and bears and dogs and vultures, through a collaboration that we have with the Zoological Society of London, and we will then be able to match, hopefully, the marks that we have on the pelvis here with the marks that we have recovered from the modern animals, and hopefully we'll then be able to say if these are bite marks and which animals caused them. York Archaeological Trust invited us to have a look at these remains because, for two reasons. One, because we've done work on animal bite marks and trauma to the bone. Dave's PhD was on traumatic injuries, and partly because we are really the only people who are doing this sort of scanning on skeletal remains as well. So the combination of those two things has kind of brought us together to have a look at this and to add a new perspective on the remains.
So we've worked in the area of looking at bite marks for a while now. We've published several papers on animal attacks on human remains. So when we came down for a preliminary study a few weeks ago, we had to look at the marks that were on the skeletons, and we've gone away and we've researched those types of marks in the literature that's available currently in the forensic context and the archaeological context.
Through our examination of the literature, we've found a number of examples of similar sorts of injuries. There aren't many. There's nothing really published in the archaeological literature, because the problem that you have there is you're never entirely sure what animals caused the damage. There are a couple of forensic examples where we've seen similar sorts of bite marks in similar sorts of regions of the body as well, and so we've been extrapolating that information to here. The next thing for us to do after we've completed the scans here today will be to take all the data back to our lab and just work through that and create the 3D models on the computer and take out all the noise and the noisy data. Once we've done that, we're able to do some of the analysis, some of the measurements, which we can take directly from these models that we're creating rather than from the actual remains themselves. And once we've done that, we will then start taking some measurements from modern material, modern bones that have been bitten by animals, and modern casts of animals as well, and we will be able to link the two together.
So this is part of the pelvis in the person who's thought to have been bitten by a large animal, and there's a mark in the bone which you'll be able to see in the display, and this is a slice taken through the pelvis, or part of the bone of the pelvis, along the line of where that bite mark is. So we can see the shape of the mark here, and this is felt to correspond to the shape of a carnivore tooth, and we can see how deep it is. And you have to remember that the pelvis, like yours and mine, is covered by quite a lot of flesh, so for the teeth to have actually bitten through into the bone, it would have had to go through the skin and the overlying flesh, and then got stopped when they reached the bone here.
This is one of the iron rings that was found together with skeleton 37. This is the ring that was found around the left leg or the left ankle, and it's been cleaned by conservators to show the original surface. So they're very simple. It's actually a single bar of iron that's been bent into a circle. It's not actually welded, so it's just got the two ends overlapping. And one of the unusual things about these leg irons was that, unlike most of the other shackles found from the Roman period, there are no chains that are linking them together. And these rings are also not wide enough to pass through the articulated foot and ankle of an adult man. So one possibility is that they were put on when the man was younger, and that they were padded so that he eventually grew into them. They could possibly have been forged around the ankles of the man in life, but this would have been very, very risky, and because of the high temperatures involved in forging, it would almost definitely have caused the almost instantaneous death of this individual. One possibility, however, is that they were forged and left partially open, and then once they were cold, they would have been sort of hammered closed using a set and a heavy hammer. It would have been risky, but it could have been achieved by a skilled blacksmith.
This is one of the pictures from the person who was wearing leg irons. It's a cross-sectional picture through the tibias, which are these bones here, and the fibulas, which are the smaller bones in the leg below the knee. This leg is normal here, and this is the thickness of the outer part of the bone and the normal structure inside the bone of the tibia. Whereas on this side you can see there's a lot of thickening of the bone around this part of the tibia, and this is where the person's had an injury when they were alive, and the bone has healed around the site of the injury to create that thickened appearance here.
We have examples from the cemetery of ritual burial processes taking place. We've got examples of bottles used for the storage of goods that would have been used during burial rituals, also feasting that would have taken place on the anniversary of these people's death. That's well documented. We have candlesticks, which again suggestive of rituals taking place at the cemetery, and also decorated vessels or tatsa, which often had incense in them that was part of these burial rituals as well. So overall, these are suggestive of the cemetery that was being used by people to record individuals who were well remembered and were respected even after their deaths. As well as the grave goods that were found in the cemetery, we had a number of finds that suggested that we had a high status cemetery. Even though these finds weren't discovered in the graves as proper grave goods, they did suggest that some high quality finds had been deposited with early burials and then been mixed up and left in later burials. For example, we have a pair of miniature silver tongues which are usually found as votive offerings in burials. Bone hairpins, again indicating fairly wealthy people who were buried with various type of personal goods. A copper alloy pelter, so this is another high quality accessory. Glass vessels, in this case it's been reworked into a disc, but the glass vessels are indicative of objects that would be buried with individuals and often have of oil or perfumes buried with the person as well. So again indicating somebody who's been respected and also has wealthy goods with them. And also a bone bridal cheekpiece, so this may well be part of a set that was buried with somebody, possibly indicating that they had been a member of a cavalry unit, for example, or were associated with horses, possibly in a gladiator situation. So overall, these are indicating a cemetery that has a rich range of goods associated with the individuals.